You can't get away from that. You get out in the wilderness, it's a plain.
They're just looking for.
Okay.
It's a great pleasure to be here with Professor Gene Odum from the University of Georgia. Professor Odum, your name is synonymous with ecology. Can you tell us about your background, please?
Well, grew up in Chapel Hill, North Carolina. It was a small town at that time. My father was a professor, and I was rather timid, and I didn't think I wanted to be a professor. I think all children tried. So I decided I wanted to be a plumber or engineer or something of that sort. Turned out later what I'm doing is looking at the plumbing of nature, in other words. So usual history, I got interested in birds and used to spend a lot of time in the woods and got to know the birds pretty well. Then I realized you don't understand anything like a bird, a piece. You have to know the whole. So I got interested in the whole environment in which birds live, you see. And so from that you go from the individual interest, you might say, then you go to a bigger level, and then now, of course, we're talking global. And ecology has sort of had the same history. We started out being like natural history, looking at things of that sort. And when I went to the University of Georgia in 1940, 60 years ago, ecology was thought to be a very unimportant division of biology. It wasn't considered something you might take after you've taken all the other biology courses. And we had a little staff meeting, and we said, what should every biologist take, what core curriculum? We always talk about that, and I suggested naively at that time that ecology ought to be something that every biologist should take, and they looked at me very stunned, stunned. Look, what's that? And he said, there's no science there because there are no principles. You see, they misunderstood what ecology ought to be. Ecology studied the whole house, you see, and they thought it was in this natural history, going out and describing, collecting, and things like that. And so that's what inspired me to write the book, Fundamentals of Ecology, which was published in '53, and it had a hard time finding a publisher because all the publishers said, we've looked at all the catalogs of all the colleges, universities in the United States, and there's not a one college that teaches ecology. Now there's plant ecology and the insect ecology and the animal ecology, but there's no general ecology. And my point is that we ought to have some principles that apply to everything. It doesn't matter whether it's plants, animals, microbes, or whatnot. And so I started writing down these principles. So my book has an unusual organization that students like, where you have a principle and you have a statement. So a sound bite, you see, a little brief statement that you can read. Then you have a little explanation, then you have examples. So the book has this organization, a statement, illustrations, examples. And it didn't really, it was, of course, there was nothing in the field. I had the field of myself there for a while. And as people began to teach more ecology and so on. And then in 1970, of course, when the astronauts got out and took pictures of the Earth, like you heard today, then that was when we had worldwide awareness. That's when we had first Earth Day and all of that. And my book was the only one, and all of a sudden the sales of the book shut up because everybody, what's this? What's ecology? So long story short, ecology has emerged now from biology. It's no longer a subdivision of biology, although this AIBS is about biology. But ecology is a discipline all its own. In other words, it's got its roots. But see, ecology now is not just about organisms. It's really a three-way interface. It's organisms, that's important, and there's the physical environment, particularly energy, and then there's people, human. So that we're looking now that ecology is a subject which involves the interaction, interfacing, and so on of people, physical environment, and so on. And early, in connection with my younger brother, we made energy as a basic. Energy is the basic for everything, and so we're trying now, you see, to use energy as a currency instead of money. You see, because you can evaluate nature services. We hear a lot about goods and services of nature, and so they can be evaluated by using a common denominator energy. my brother and I have a little paper, three-page paper summarizing all that in the new journal called Ecosystems. Is a new journal. So we essentially, ecology is increasing its scale. And then that's problems because when you get to the big scale, you can't be real exact. You see, so people ask, Mr. Scientist, is it really having global warming? And we'll have to say, well, we think so, but we're not real sure, you know. And so the public says, poo-poo, that science don't know anything, you see, so they don't pay attention to it.
Very interesting, because just as you recounted, I was given assigned your textbook, I think in the 1970s, a yellow cover. Was it always with a yellow cover?
That was the third edition. Yeah, the first one was red, and the second was green, the third one was yellow. Yeah, that's third.
And for that many years, it was the only text in ecology.
It's true.
You helped to define the field.
Yeah, most people teach ecology as evolutionary biology, which is all right. But that's just part of it. And people who think ecology is just evolution. First, second thing, see, human beings are no longer under natural selection, so to study the evolution of the past doesn't help us at all, because we recreate our genome, we don't select people, we keep all the misfits alive, and so on and so forth. So we have to go another step above that. But
You talked about ecosystem services just a moment ago. What are some of the services that we get from these ecosystems?
eating, drinking, and breathing. Breathing and drinking. You see, we don't pay any money for that. We call these non-market services, and we have to either get them in the market or give them some value. You see, you can't live more than 2-3 minutes without breathing, and you can't live very long without water. I expect right now water, clean, quality, fresh water is a big limiting factor, and so on. Our prediction, Gary Barrett and I have an article coming out in the Bioscience, and our prediction is, see, there are two kinds of growth. There's what we call the exponential growth, very fast, very rapid, like Atlanta or Washington. They're growing very, very fast. Then there's the controlled growth that you see both kinds of it, but the controlled growth is where you start leveling off before you reach some limit. So what we say is the human mindset is so oriented to fast growth that what we're going to have is we're going to go too far, and then we're going to have to downsize. So we predict in the future we're going to have many booms and busts. And it's all right. Humans are pretty good at we're awful good at getting out of trouble, you know. We get ourselves in a mess, you know, and we sometimes get. So the population, you see, the Earth will go too big. I don't think $12 billion nobody can have a quality of life for that many people if they have demands that we have. And so we'll go up maybe to 10, and then we'll downsize, and we'll have a negative population growth. So our prediction is boom and then bust, and then we'll come back to what we call the optimum, you see, where you don't live on the edge. If you're living on the edge and anything happens like a drought, then everybody starves. So you don't want to be right on the maximum. You see, you want to. So the optimum is always less than the maximum, and people can't understand that. You know, there's a point where too much of a good thing that's what we have now. We have too many cars, they're good things. We have too many people, they're good things. But when you get too many of them, then that's worse than having not enough. So that's our general message. Yeah.
Your field has changed tremendously. What were the most significant changes in the field of ecology over your career?
Well, just that, getting ecology to go beyond biological science. It's not a. See, the word comes from Greek word oikos, which is household, and so we're now treating ecology the way it should be, according to the name. It's to study the whole household. And see, most science is going the other way. Most science is going reductionist. In fact, in many biology departments, ecologists are no longer welcome. It's all reduction, molecular, and genetic, which is fine. But it's like Lynn Margulies said today. You know, that's an important part. But then you don't want to continue to have more and more study of less and less. You see, so ecology has a tremendous, importance here to put the pieces together. And when you put the pieces together, we get what we call emergence. In other words, if you put or complex systems that everybody's talking about today. A complex system is something you can't understand just by understanding the pieces. You might know everything about every species and everything about that, but when you put them together, there's new properties pop up. A good example is water. There's oxygen, hydrogen, very reactive stuff. You put them together in a certain way, you get water which has this properties, nothing at all like hydrogen, oxygen. And so if you want to study water, do you study hydrogen, oxygen? No, you study water. You see. So we have to get the idea is that scientists tend to work on little pieces, and as I said, you can be more precise the smaller your thing is. When you get to the big picture, you can't be precise. And so people don't understand that, and they expect us to be very precise, you have global warming. Well, there's a lot of things that are cooling areas. We're putting up all these aerosols, and cutting out the sun. And so we think we're warming, but we're not sure. So that this is a new level of science where you have to have different criteria and so on. And the main thing is exciting to me is getting people in. Of course, my father was a sociologist, so I came by this naturally. His famous book was Southern Regions, in which he tried to show what was wrong with the South. He asked the question, why is the South doing so poorly? And the answer is fairly simple. Of course, segregation was not helping us. And then we had the world's worst farming, ruined all of it. All of our soil disappeared. And then we had no high-quality education. You had to go out of the South to get an education, a PhD, for instance. There was no single school in the South at the time. So we were real pleased, In a recent survey, our ecology group at Georgia is number 5 in the nation. So people are coming out to us because we didn't have any ivy on the wall. So we could develop a new way of looking at things. Whereas if you're Yale and Harvard and so on, you have to wait till all the prima donnas die before you can get in there. Whereas when I went to Georgia, there was nobody there but the young people, most of whom was planning to leave sometime because the school wasn't very good. So we learned to get outside money. So we had what we call satellite program. We still do. We have a Savannah River program at Savannah. We have a big program on the coast, Marine Road. We have Coweta, which is a big watershed laboratory. So by getting money from outside, then we could bring in new people and build up a staff that you couldn't afford if you just depended on the inside money. So a little bit of financial management comes in there. Mm-hmm.
Just earlier in the conversation, you talked about how ecology now wasn't such an easy time for the field. What would be your advice to ecologists to strengthen the field?
Mm-hmm. Well, the exciting thing now is for people from other disciplines. I guess let's put it this way: ecology exciting now because it interfaces so well. They all say ecological economics. You see, there's new journals, new books and everything, and new ways of thinking about that. And then there's ecotoxicology, you see, and then there's agroecology. All of these things we've had to work in. In other words, the new agriculture, you see, must be preserve the soil rather than mining the soil, you see. And we have a whole new way of doing things we call conservation agriculture and so on. And so to get into the interfaces, in other words, the ecology is exciting because we need and we draw from almost any other discipline, including the humanities and the social sciences. You see, in Georgia we now going to have a new umbrella school called School of Environment. Not environmental science, environment. That leaves it open for anthropologists and sociologists, and then we'll have some special money only for people who want to cross boundaries. So crossing boundaries now has to be it because let's put it this way: no real world problem can be solved by any one discipline. Period. The economists can't do it; they're ruining it because the market system does not give any value to the non-market ecosystem services. So we have to work together with them to expand the economy, to give value to what we call life support services. You see, not paying much for water, just pay for pumping it. We don't appreciate it. We don't pay anything for air. You see, so either we got to put prices on it, and already, of course, water. We're going to be having to raise the price of water as they do in the West already, because we waste it. We have to have lawns that don't need watering. Things like that. You have perfectly good lawn without water and needing it watering. It's so kind of grasses and ground cover and dandelions, things like that. Pretty. I think the green manicured lawn is ugly to me. People think you must. See, we got the human traditions that we're going to have to change.
It's been such a great pleasure to talk with you today.
Yeah,
Thank you so much.
Enjoyed it so